Hey guys, what do you call a man with no body and just a nose? Nobody knows. Nobody knows, get it? Okay, this is a review on graphing 4.3a. To be successful in this lesson, this is what you should be able to do by the end, I can graph a linear function by setting up a table and using the slope and y-intercept. So there's two methods we're going to look at. We're going to review some vocabulary. This is the table method. We're going to look at that first. Then we're going to look at the y-intercept and slope method. I actually just kind of abbreviate this and call it the slope method, okay? So here we go. Let's look over some vocabulary real quick. Remember, a linear function is an equation of this form, y equals mx plus b, where m represents the slope of the line and b represents the y-intercept of the line. Now, remember, this definition is a little bit not totally accurate because a linear function could look differently than this, but it could always be put in this form with some algebraic steps. So if it's a linear function, it can always be put in this form, but it doesn't necessarily always have to look like this from the start. Remember, slope is rise over run. So if you had an equation like y equals 3x plus 1, the 3 you could always put into a fraction form, where you'd have a rise of 3 and a run of 1. Where the line intercepts the y-axis is simply termed the y-intercept. So this point right here, where this yellow line is going through the vertical axis, the y-axis here, that's called the y-intercept because it's intercepting or intersecting the y-line, okay? So that's just some old words we've known in the past. Just want to review them with you. Let's go into our first of two examples, so it shouldn't take us too long here. This is the table method. So this isn't my favorite method, but it's a method that you do need to know how to do. So the first thing I got to do is I kind of want to get this equation into the y equals mx plus b form. So my first step is to solve for y. Okay, that's the first thing that I need to do. Solve for y. Get it into that y equals mx plus b form. So I want to get rid of this 2. So I'm going to divide by 2 because it's 2 times y, and these 2's will cancel if I do that. But I also have to divide everything else by 2 here, right? So, because whatever I do on the left, I got to do on the right. So 4 divided by 2 is 2. So that gets me 2x, and this gets me 1. So I'm left with just y, okay? I'm going to rewrite this because this looks silly. I'm left with just y on the left. So y equals 2x plus 1 because I divided everything in this equation by 2, okay? Now from here, the next step for this method is to set up a table. Set up a table. So that can be really simple. You can keep your table whoops, let me undo that line. You can keep your table kind of neat and clean. And then the third thing you're going to do is plug in some x values. Plug in some numbers for x. Okay? So they can be any numbers. You just want to pick numbers that are going to be on your graph. So I like to pick 0 because 0 is easy to calculate. So now you have to think, okay, when x is 0, what's y going to be? Y equals 2 times x, or 2 times 0 because I'm plugging in 0 for x, plus 1. So what does y equal? That's the question. What does y equal here? Well, 2 times 0 is 0, and 0 plus 1 is 1. So y is 1 in this case. So that leaves me with the x and y of 0, 1. So my x is 0 and my y is 1. Or I could say when x is 0, y is 1. Okay, I'm going to plug in another point. I'm going to plug in maybe 3. Okay, so y equals 2 times 3 plus 1. 2 times 3 is 6, and 6 plus 1 is 7. So when x is 3, y is 7. So I have the point 3, 7. So now I just graph these 2 points on my coordinate grid. So I graph the point 0, 1. 0 means don't go left or right. 1 means go up. Go over 3, 1, 2, 3, and up 7. 1, 2, 3, 4, 5, 6, 7. Okay, and once I've done 2 points, that is enough to graph a line. I like to do 3 just to make sure that they're on the same line so I didn't make a calculation mistake. But for the sake of this example, I'm just going to do 2 to make it go a little faster and smoother. But you really only need to do, you really should do, 3 just to make sure that you get them on the same line. Well, let's see if I can make this line a little straighter here. There we go. Okay, and remember this line is going to be extending forever in both directions. So I like to put, a little arrow on the ends of it. And I want you to note that every point on this line, anywhere on this line, has an x and a y number, even if it's like a fraction, okay? And every point is a possible solution for this equation, or it's an x and a y number that makes this equation a true statement. So that's all there is to graphing using the table method, okay? The last method here I'm going to show you is my favorite. It's the slope and y-intercept method. But again, the first step in solving or in graphing things like this is to solve for y. This is actually even more important than we solve for y because we need that form of y equals mx plus b to graph using the slope and y-intercept method. So the first thing I'm going to do is I'm going to simplify what I see on the right-hand side here. I'm going to rewrite what I don't mess with. But I need to distribute this -3 to both terms because this is kind of messy, right? So this is -3 times x, so that gets me -3x. And then -3 times a +4 is -12, okay? And now I still have one more step to do to solve for y. This is 3y, so I've got to divide by 3. When I divide all the terms by 3, I'm left with just y, okay? So that leaves me with just y equals the -3 divided by 3 is just -1, so -x, and then -12 divided by 3 is -4, okay? So I want you to remember in this method that b represents the y-intercept, m represents the slope, okay? So the second step is to graph the y-intercept, because that's the easiest thing to do here first. If my y-intercept is -4, well, that means that I'm going to have to plot a point here at -4 on the y-axis. 2, 3, 4. And then the next step after you graph the y-intercept would be to use the slope to graph additional points, to graph more points. Okay, and that's all there is to this. Now I want you to notice that our slope is negative. It's a -x. What does that mean? Well, that means that there's like a -1 here because -1 times x is -x. So our slope is a -1/1. Now, if your rise is negative, go down. So what I like to do is I like to put my pencil, the tip of my pencil right on the y-intercept point that I graphed, okay? And now I'm going to follow my slope. The top number here is going to tell me go down 1. So I'm going to go down 1. Then the bottom number tells me to run right 1. So I'm going to go right 1. So I can repeat that down 1 over 1, down 1 over 1. I can repeat that forever, and I'll have a set of points that are in a line. Here's something to remember. The numerator, or the rise could be up or down. Okay? The run right here is always to the right. Always to the right. The only time we go down with the rise is if it's negative. Otherwise, we go up. Okay, so after we graph these points, we connect them with a line, and we're done. If my line will come up, I'll connect them with the line for you. Here we go. Let's see if I can get it to work. There we go. And this line extends forever in both directions, which is kind of cool. All right, so that's the slope method, and we had gone over this in centers in class. So this is just to ring the bell, help you remember, graph those lines on the assignment, and do a good job, guys. And don't be intimidated by the fact you may have to solve for some y's. You can do it. You got some equation skills now. Before I sign off, though, there's a number clue for you. The number clue is it's 4 more than a multiple of 5. All right, guys, thanks for listening.